This funnel, it is written on northern hemisphere. We are in the north. Hello there, once again my name is Hamza Luwama and I'm here live at the Equator once again, and today I want to share with you the concept of Coriolis effect, the concept or the phenomenon which talks about movement of air in the atmosphere, and as the air moves in the atmosphere, it moves in a way that in the northern hemisphere it is moving in a clockwise direction, whereas in the southern hemisphere it is moving in the anti-clockwise direction. Now when you get to the equator line, like I am right here, this wind or the air does not cross the line, but rather it blows in the cyclic form, and that one which is in the northern hemisphere goes northern in a clockwise direction, whereas that one which is in the southern hemisphere goes in the anti-clockwise direction. Now this phenomenon makes liquids, makes air molecules move in those different directions depending on the hemisphere you're in. Remember, the hemisphere is half of the earth. So we have the northern hemisphere and the southern hemisphere. So people who are in the northern hemisphere, the wind blows and the liquids move in the direction which is clockwise. Then those in the southern hemisphere, they are blown in the anti-clockwise direction. More of these illustrations, we can see them when someone fires a bullet, does not go straight to that person in a straight line. The bullet takes a curve. Even aeroplanes do not fly so straight in a line, but they take a bend. Reason being, the air molecules play a role of bringing what we call resultant velocity. As the wind blows the plane ends up taking a different lane. The same applies to ships. When ships are sailing on water, they do not take a straight path, but rather they end up passing through a trajectory which is in a curved nature. It's because of Coriolis effect. So this effect is very important in our lives, and also we have an experiment here in Uganda which you can use to demonstrate. Right here we have the zero latitude experiment. Right there we have the experiment in the northern hemisphere, and then on my left I have the experiment in the southern hemisphere. So tour with me, join me as we explain the physics behind, and we see what happens in the northern hemisphere using the Coriolis effect. So please join me. Okay, so here we are now in the northern hemisphere. As you can see this funnel, it is written on northern hemisphere. We are in the north, and I'm joined by a gentleman who is helping me with this experiment called Alfred Pasco, and he's going to help us demonstrate how the water spins, because I've told you this Coriolis effect curves winds, curves fluids, curves air, which is moving in the atmosphere. So we are going to see how the Coriolis effect curves wind or air or liquids in the northern hemisphere, and then we do a comparison with the southern hemisphere, and then we shall also do a comparison at the equator where we have the 0 degrees of the angle of inclination of the Earth's axis. So can we proceed? So here we are filling our funnel with water, and thereafter we are going to release the water through the funnel. First, you stabilize the water so that water is not rotating in any direction. You make sure the water is calm, it is stable. That's why he's using this semicircular plate to stabilize the water. After stabilizing it, you can now release the water through the funnel, as you can see. Then he can put for you this flower to show you the rotation. As you can see, this rotation is actually clockwise in the northern hemisphere. It's because of the Coriolis effect, because the wind in the atmosphere is blowing in the clockwise direction, as the wind in the southern hemisphere is blowing in the anti-clockwise direction. We're going to take a look at the experiment on Coriolis effect using the southern hemisphere funnel. this funnel is in the southern hemisphere, and we want to pour our water the same way we did, and we see what is expected to happen. And then also, you'll take note that whenever you are close to the equator, the speed of the water reduces because of the centripetal force of the earth. So when you go further away, the speed of the water increases. It's the same reason why we have a less weight when we measure ourselves here, yet when we go further away from the equator, we make our weight be a little bit increased because we have less effect from the centripetal force. So, Alfred, can we pour our water once again? So still, when you fill the water, we have to get this semicircular blade and stabilize the water to confirm that the water is not biased at any one point. It's not running as a result of maybe some external forces. So after stabilizing the water and release it, we are going to use our demonstration flower again. Now this time round, the demonstration flower is rotating in the anti-clockwise direction. That is because of Coriolis effect, which makes the wind and fluids curve in space or in the atmosphere. So the last demonstration on this is going to be experienced when we are at the equator line. So follow me as we join the equator line. So here now we have joined the equator line. We are at 0 latitude, and at this point I told you the wind blows in this format. In that format, the wind does not cross. So in that sense, we do not have any air effect that is going to be experienced just at the equator line. Some people think this distance is too small between the equator line and the experiment positions we chose, but in actual sense, this can be a very good illustration of what I'm talking about. So Alfred, can we now investigate at the 0 altitude? And when you pour the water and stabilize it, still we have to see what effect is it going to cause. Our semicircular blade is doing a good job of stabilizing the water so that the water is not affected by any external forces. So we release the water at once. So here we are, and there we go. So when you put our flower this time round, it does not make a spin. It's because here at the equator line, we are not experiencing the effect of the air molecules that are moving in the northern hemisphere and the southern hemisphere. And remember, in the northern hemisphere, they are moving clockwise, while in the southern hemisphere, they are moving anti-clockwise because of the Coriolis effect. So for that reason, we are having what we call the Coriolis effect, and it has helped people in the world to get to know how some of these items, for example, why bullets are fired and they deviate, why ships don't move in a straight line, why planes also don't take a straight path in space, because the wind up there plays a very big role in blowing them, and they end up taking a curved path rather than a straight path. I'm still Hamza Luwamba. Still join us as we take you through the science and the physics behind the equator line and our Earth. Thank you so much.